NENOMATICA, where mathematics meets YouTube excellence. The seventh law of power. Welcome to our lesson on working with exponents. Today we'll explore how to simplify expressions involving exponents using various exponent rules. Let's start with our first example. We need to evaluate the expression 5 raised to the power of -3 divided by 5 raised to the power of -2. When we divide exponential expressions with the same base, we can use the division rule of exponents. Let's recall this rule. Applying this rule, we subtract the exponents. So 5 raised to -3 divided by 5 raised to -2 equals 5 raised to -3 minus -2. Next, we combine the exponents. -3 plus 2 gives us -1. Remember, when a number has a negative exponent, it equals 1 divided by the number raised to the positive exponent. So 5 raised to -1 equals 1 divided by 5 raised to 1, which simplifies to 1/5. Let's move to our second example. Here we have a more complex expression. 5 raised to -15 times 5 raised to 4, divided by 5 raised to -3 times 5 raised to -4. Let's start by simplifying both the numerator and denominator separately using the product rule of exponents. In the numerator, -15 plus 4 gives us -11. In the denominator, -3 plus -4 gives us -7. Now, we can apply the division rule of exponents. When dividing powers with the same base, we subtract the exponents. This simplifies to 5 raised to -11 minus -7, which equals 5 raised to -11 plus 7, or 5 raised to -4. Finally, using the negative exponent rule, 5 raised to -4 equals 1 divided by 5 raised to 4, which equals 1 over 625. Now for our third example, we have 2/3 raised to -3 multiplied by 2/3 raised to 2. When multiplying expressions with the same base, we add the exponents. So we have 2/3 raised to -3 plus 2. -3 plus 2 equals -1. So we have 2/3 raised to -1. For a negative exponent with a fraction, we can apply the rule that a fraction raised to a negative power equals the reciprocal of the fraction raised to the positive power. And that's how we work with exponents. Remember to apply the appropriate rules: the product rule when multiplying with the same base, the division rule when dividing with the same base, and the negative exponent rules for handling negative powers. These rules allow us to simplify complex exponential expressions systematically. In this video, we'll solve an exponent problem step by step, applying the rules of exponents. Here's our first example. We need to evaluate the expression where we have the quantity 3 to the -2 raised to the power 3, then the entire result raised to the power 3 multiplied by 3 to the 5th power raised to the -2. Step 1, let's expand the powers. We'll use the power of a power rule, which states that a to the m raised to the power n equals a to the m times n. When we apply this rule to the left part, 3 to the -2 raised to the power 3 becomes 3 to the -2 times 3, which is 3 to the -6. Step 2, simplify the exponents. -2 times 3 equals -6, and 5 times -2 equals -10. Step 3, apply the power of a power rule again. For the first part, 3 to the -6 raised to the power 3 becomes 3 to the -6 times 3, which is 3 to the -18. Step 4, add the exponents. We'll use the product of powers rule, which states that a to the m times a to the n equals a to the m plus n. So 3 to the -18 times 3 to the -10 equals 3 to the -18 plus -10. Step 5, simplify the exponent. -18 plus -10 equals -28. Step 6, write the answer as a reciprocal using the negative exponent rule. This rule states that a to the -n equals 1 over a to the n. So 3 to the -28 equals 1 over 3 to the 28th power. Now, let's look at a general pattern. We have the quantity a to the -m raised to the power n multiplied by the quantity a to the -n raised to the power -m. Step 8, expand each power. Using the power of a power rule, a to the -m raised to the power n becomes a to the -m times n, and a to the -n raised to the power -m becomes a to the -n times -m, which is a to the positive n times m. Step 9. Add the exponents using the product of powers rule. a to the negative m n times a to the n m equals a to the negative m n plus n m. Step 10. Simplify the exponent. Negative m n plus n m equals 0, since these terms cancel each other out. Step 11. Apply the zero exponent rule. Any non-zero number raised to the power of 0 equals 1. Finally, let's look at a division example. We have x to the power n divided by x to the power n plus 1. Step 13. Subtract the exponents. We'll use the quotient of powers rule, which states that a to the m divided by a to the n equals a to the m minus n. So, x to the n divided by x to the n plus 1 equals x to the n minus the quantity n plus 1. Step 14. Simplify the exponent. N minus the quantity n plus 1 equals n minus 1. Step 15. Combine like terms. N minus n equals 0, so we have x to the negative 1. Step 16. Write as a reciprocal using the negative exponent rule. X to the negative 1 equals 1 over x to the 1, which is simply 1 over x. Welcome to our algebra lesson. Today, we'll explore how to simplify algebraic expressions by working with exponents and their properties. Let's start with our first example. We need to find the value of this expression. Let's begin by simplifying this expression step by step. First, let's combine the second and third terms by using the property that when we have a negative exponent multiplied by a positive exponent, we can subtract the exponents. Next, we simplify the exponent by calculating 5 minus 3, which equals 2. So we now have 2 times a to the negative 5 times 2 times a to the power of 2. Now, let's expand the expression 2 times a to the power 2 as 2 squared times a squared. We can separate the 2 and the a because each is raised to the same power. Let's continue by adding like terms. We'll add the exponents of it together. Negative 5 plus 2 equals negative 3. And we'll multiply the coefficients. 2 times 2 squared equals 2 times 4, which is 8. Now, we can express a to the negative 3 as 1 over a cubed, which is another way to write a negative exponent. We can write 2 cubed times the fraction 1 over a cubed as 2 times 1 over a all cubed. Finally, we can simplify this to 2 over a all cubed. This is our final answer. Let's solve another example. This time we have a more complex fraction expression to simplify. Let's start by combining all terms in the numerator. We add the exponents. Negative 3 plus negative 2 plus negative 4 plus 5. Now, let's simplify the denominator. We need to compute x to the power of 5 divided by x to the negative 3 to the power of negative 3. Let's now multiply negative 3 by negative 3 in the exponent of the denominator's second term, giving us positive 9. Now, remember that division by a power means multiplying by its reciprocal. So x to the 5 divided by x to the 9 is the same as x to the 5 times x to the power of negative 9. Simplifying the expression in the denominator, 5 minus 9 equals negative 4. Notice that we now have x to the negative 4 in both the numerator and denominator. When dividing by the same base with same exponents, the result is 1. Multiplying these terms means adding the exponents. Negative 4 plus 4 equals 0. So we have x raised to the power of 0. And any number except 0 raised to the power of 0 equals 1. Thus, our final answer is 1. And that's how we simplify algebraic expressions with exponents. Remember the key rules we used: the product rule, power of a product rule, and especially how to handle negative exponents. Practice these techniques to become proficient in algebra. Welcome to our video on exponent rules and operations. Today, we're going to solve some exponent problems step by step, focusing on how to simplify expressions using the laws of exponents. Let's start with our first example. We need to calculate a raised to the power of m plus n divided by a raised to the power of 2n minus 1. Remember, when we divide expressions with the same base, we can subtract the exponents. Let's apply this rule to our problem. Step 1. Let's apply the division of powers rule. We have a to the power of m plus n minus the denominator exponent, which is 2n minus 1. Step 2. Let's expand the exponent expression in the parentheses. We get m plus n minus 2n plus 1. Step 3. Let's combine like terms in the exponent. We have m plus n minus 2n, which simplifies to m minus n plus 1. Therefore, our simplified answer is a to the power of m minus n plus 1. Now, let's look at the next example from our image. We have a to the power of m plus n divided by a to the power of 2n minus 1. Let's solve this step by step, following the approach shown in our image. First, we simplify the numerator by applying the division rule of exponents. The numerator becomes a to the power of m plus n minus parentheses, m minus n. Let's expand the expression in the numerator. We get m plus n minus m plus n, which simplifies to 2n. Now, we apply the division rule again to simplify the entire fraction. We get a to the power of 2n minus 1. Let's simplify this expression. We get 2n minus 2n plus 1, which equals 1. Therefore, our final answer is simply a, since a to the power of 1 is just a. Let's move on to our next example, which involves working with negative exponents. Here we have x to the power of negative 5 divided by x to the power of negative 3, all divided by x to the power of 5 divided by x to the power of negative 7. When working with negative exponents, remember that x to the power of negative n equals 1 over x to the power of n. Let's start by applying the division rule to both the numerator and denominator. In the numerator, we have x to the power of negative 5 minus negative 3. In the denominator, we have x to the power of 5 minus negative 7. Now, let's simplify both expressions. In the numerator, negative 5 minus negative 3 equals negative 2. In the denominator, 5 minus negative 7 equals 12. Now, we can apply the division rule to the entire fraction. We get x to the power of negative 2 minus 12, which is x to the power of negative 14. Therefore, our final answer is x to the power of negative 14. Welcome to this mathematics tutorial. In this video, we'll solve a few problems involving exponent properties. We'll follow a step-by-step approach to clearly show how to work with expressions containing exponents. Let's examine our first example. We need to simplify the expression 3 squared times 4 squared times 12 to the power of 5 divided by 2 to the power of 4 times 6 to the power of 4. First, let's rewrite the expression by breaking down 12 as 2 times 3 and 6 as 2 times 3. This allows us to work with the same base numbers. Now, let's expand the expression. We'll focus on rewriting 4 squared as 2 squared squared, and expand the powers using the property that when raising a power to another power, we multiply the exponents. Next, we'll apply the distributive property of exponents. When we have a product raised to a power, each factor in the product is raised to that power. This helps us separate the terms with the same bases. Now, we'll group the terms with the same base and then combine the exponents. For terms with the same base, like 2 and 3, we can add their exponents when multiplying and subtract exponents when dividing. Let's combine the exponents. 3 to the power of 2 multiplied by 3 to the power of 5 gives us 3 to the power of 7. Similarly, we combine the other exponents. Now, we can rearrange this expression as a product of divisions, separating the terms with base 3 and base 2. When dividing powers with the same base, we subtract the exponents. So 3 to the power of 7 divided by 3 to the power of 4 equals 3 to the power of 7 minus 4, which is 3 to the power of 3. Finally, we simplify the expression to get 3 cubed times 2 to the power of 6, which is our final answer. Now, let's move on to our second example. We need to simplify the expression x to the power of 5 times y to the power of 4 divided by x squared times y times c cubed. To solve this problem, we'll start by rewriting the expression as a product of powers. For each variable, we'll subtract the exponents in the denominator from those in the numerator. Now, let's simplify the exponents. X to the power of 5 minus 2 equals x cubed. Y to the power of 4 minus 1 equals y cubed. And 1 over z cubed remains the same. Let's rearrange our expression to get a single fraction. We can simplify the numerator by grouping the x and y terms together. Finally, we can rewrite this as a single term to the power of 3. Our final answer is xy over z, all raised to the power of 3. In this video, we'll solve two exponential expressions from the given examples. Let's look at our first example. First, let's recall the rule for dividing by a negative exponent. When we divide by a number with a negative exponent, it's equivalent to multiplying by the same number with the positive exponent. Now, we have 10 to the power of 5 multiplied by 2 to the power of 5. Let's use the power of product rule to rewrite this. Next, we calculate 10 multiplied by 2, which is 20, and keep it raised to the power of 5. Let's move on to our second example, which is more complex. To solve this expression, we'll first rewrite each term as a power of 2. This will make it easier to combine everything into a single expression. Now we'll apply the power of a power rule, which states that when we have a power raised to another power, we multiply the exponents. Let's calculate the exponents. 4 times 3 equals 12. Negative 1 times 5 equals negative 5. For the denominator, negative 2 times negative 3 equals positive 6. And 3 times negative 7 equals negative 21. Now let's apply the product rule for exponents, which allows us to add exponents when multiplying powers with the same base. Next, we'll use the division rule for exponents. When we divide powers with the same base. Example, let's solve the expression 2 to the power of 5 times 5 to the negative 5 times 2 to the power of 10 times 5 to the negative 10, continuing the pattern with similar terms until we have 2 to the power of 100 times 5 to the negative 100. Let's start by grouping like terms. We'll group all the powers of 2 together and all the powers of 5 together. This allows us to use the product rule of exponents. Now, we'll apply the product rule of exponents to each group. When we multiply powers with the same base, we add the exponents. Let's calculate the sum of the exponents. The powers of 2 follow the pattern: 5, 10, 15, and so on, up to 100. This is an arithmetic sequence with first term 5, last term 100, and common difference 5. Looking at the pattern, we can see that we have the values 5, 10, 15, 20, and so on up to 100. These are multiples of 5 from 1 to 20. So we have the sum of 5 times the numbers from 1 to 20. Similarly, for the powers of 5, we have minus 5, minus 10, minus 15, and so on down to minus 100. We can simplify the expressions in the exponents. For the power of 2, we have 20 divided by 2 times 5 plus 100, which equals 10 times 105, which equals 1050. For the power of 5, we have 20 divided by 2 times negative 5 plus negative 100, which equals 10 times negative 105, which equals negative 1050. Now, we'll use another exponent rule to rewrite the negative exponent. A negative exponent means the reciprocal of the base raised to the positive exponent. Let's simplify 5 to the power of negative 1. This equals 1 divided by 5. Now we can combine these terms. We have 2 times 1/5 raised to the power of 1050. Let's simplify the expression inside the parentheses. 2 times 1/5 equals 2/5. That's our final answer for the first problem. Now, let's move on to the second example. Example, let's solve the expression. The fraction 2/5 to the power of negative 7 times the fraction 5/2 to the power of 3 times the fraction 4/25 to the power of 4. Let's start by rewriting the third fraction. We can express 4/25 as 2 squared over 5 squared. Next, let's use the power of a power rule to simplify the last term. When we raise a power to another power, we multiply the exponents. Now, let's use the negative exponent rule again. We know that a to the power of negative n equals 1 over a to the power of n. So 2/5 to the power of negative 7 equals 5/2 to the power of 7. Let's combine the terms with the same base. We have 5/2 to the power of 7 plus 3, which is 5/2 to the power of 10, and we have 2/5 to the power of 8. Now, notice that the fractions are reciprocals of each other. We can rewrite 2/5 as 1 over 5/2, or as 5/2 to the power of negative 1. Using the power of a power rule, 5/2 to the power of negative 1, all raised to the power of 8, equals 5/2 to the power of negative 8. Now we can apply the product rule again to add the exponents. We have 5/2 to the power of 10 minus 8, which equals 5/2 to the power of 2. Therefore, our final answer is 5/2 squared. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.